Optimizing design for flexible circuits, best practices and advanced design strategies. Flexible circuits are at the heart of today's most compact and advanced electronics across aerospace, medical devices, and everyday tech. But designing them well? That takes more than just electrical know-how. You need to think mechanically too, to make sure they're built to last. In this video, we're breaking down proven design strategies paired with visuals to help you create flex circuits that are smarter, stronger, and built for the real world. Let's start with something fundamental: dynamic versus static applications. If your circuit is in constant motion, like inside a robotic joint, you're designing for dynamic use. That means you'll need materials and layouts that can flex repeatedly without breaking down. But if your circuit only flexes a couple times during installation and then stays put, that's static. In those cases, you can focus more on compactness and performance over endurance. Now that we've covered the basics, let's talk about one of the most important design choices: where you place your conductors. Conductor placement and bend area design. To minimize strain and keep your circuits healthy over time, place conductors along the neutral axis of the flex region. When designing bends, keep signal traces on the inside, where they're compressed, not stretched. Ground planes can go on the outside, where they handle tension better. And here's a critical rule: avoid putting plated through holes, pads, or sudden trace width changes in the bend zone. Those are all stress magnets. Next up, let's talk about how tight you can bend your circuit without compromising its lifespan. Too tight, and you'll have fractures in no time. Stick to these guidelines: single-sided circuits, 3 to 6 times the thickness; double-sided, 6 to 10 times the thickness; multi-layer, 10 to 15 times. Dynamic applications, 20 to 40 times the thickness. More room means less stress. It's that simple. Speaking of stress, let's look at a common mistake that puts circuits at risk: avoid stacked traces or I-beam layouts. In double-sided designs, don't line up conductors directly over one another. That's called an I-beam layout, and it focuses strain right through the middle. Instead, stagger the traces. It spreads out the load and boosts durability. Now let's move on to a subtle design trick that can make a big difference when combining stiff and flexible areas: strain relief at rigid sections. Whenever you're using stiffeners like FR4, add some potting material between the stiffener and the flex. This softens the transition, like shock absorbers for your circuit, and helps it survive repeated bends. Next, let's talk about tearing and how to keep your flex circuits from ripping under pressure. Boosting tear resistance. Tearing is another flex circuit killer, but a few smart design moves can make a huge difference. First, use large radii in corners instead of sharp angles. This helps spread out stress and keeps cracks from forming. Next, consider adding embedded glass cloth. It acts like internal armor, improving the overall structural integrity. A recessed slot paired with a relief hole can reduce the chance of a tear starting in slits or cutouts. Also, drilling a hole right at the corner helps disperse stress. This small detail goes a long way. For added strength, you can embed aramid fiber. It's incredibly tough and resists tearing even under strain. And finally, use extra copper in the corners. These areas take on a lot of stress, and reinforcement here adds durability where it's needed most. Individually, each of these changes is simple, but together, they make your flex design a whole lot tougher. While we're on the subject of rugged environments, here's how to handle vibration and shock. If your application involves vibration or impact, like in a vehicle or aerospace system, you need to anchor your flex. Use fasteners, clips, screws, or relief bars to lock things down, and add mounting holes to stabilize the layout and prevent tearing under movement. Let's now shift focus to another small detail that can have a big impact: pad filleting and trace routing filleting. Rounding out the connection between pads and traces helps distribute stress and prevents cracking. Also, steer clear of sharp trace corners. Use smooth curves with radii instead to reduce stress concentrations or stress risers that can trigger failure. Next up, tolerance and alignment. For accurate assembly, place multiple fiducials. They help keep everything aligned during manufacturing so components land exactly where they should. And while you're designing for precision, don't forget about flexibility, especially when it comes to your ground planes. To keep your flex circuit truly flexible, crosshatch the ground planes. And during soldering, use thermal reliefs on ground connections so heat doesn't get trapped and damage joints. What about unsupported mounting holes? Here's a quick fix to prevent them from becoming weak points. If a mounting hole isn't backed by a rigid section, keep the copper around it. It adds structure and prevents tearing at a weak point. Now let's cover how to maintain a permanent bend. Want your flex circuit to hold a bent shape? You've got options. Widen the copper traces, use thicker copper, or apply heat forming to lock in the curve. This is especially useful for applications that need the circuit to stay in place. And finally, let's talk sustainability. Nesting for material efficiency. Flex circuits often have odd shapes, but smart nesting during panelization reduces material waste. For dynamic circuits, align conductors with the copper grain direction to improve fatigue life. And if folds are part of your layout, make sure pad orientation is correct before and after the fold. These choices don't just save cost, they support more sustainable manufacturing too. Designing flexible circuits requires integrating mechanical and electrical principles to ensure long-term performance. By following best practices, like proper conductor placement, bend management, and avoiding high-risk areas, you can greatly enhance reliability. Adapting these strategies to your application leads to stronger, more efficient designs. At PICA Manufacturing Solutions, we're committed to advancing circuit design. Want the full white paper? Download Optimizing Design for Flexible Circuits at picamfg.com/pica-white-papers. Have questions or a project in mind? We'd love to help. Just give us a call at 855-742-2634 to speak with one of our engineers. Thanks for watching.